Good morning, class, and welcome back to the class. And this is our first chapter, measurement. All right, chapter one, which is of your physical science of class 9. And then we were actually discussing about measurement since the last class. Okay, and to know much about it, the introduction of it, you can see the first video. All right, which was given to you before this. So now let us continue with the topic on measurement. So today what we are going to actually discuss, we are going to see what are the what is the necessity of differently sized units for measuring the same physical quantity. Okay, so what is the necessity? है ना? हामीले चाहिँ किन चाहिँ we need that there should be differently sized units for measuring same physical quantity. Okay, so let us consider, we are considering it as length. Okay, for now we are considering length. So to consider length, what we discussed that there was a standard unit which was called as a meter. All right. So now let us see. Since we are talking about meter out here, so let us consider we have a pencil of 15 centimeter. Okay. So we have a pencil and it is of 15 centimeter. Let's say we can have an idea about the length of the pencil very easily. Yes or no? है ना? We have a pencil and which we say that it is 15 centimeter. So if somebody tells you that I have a pencil of 15 centimeter, obviously you people can make an imagination out of it. होइन तिमीहरूले बुझ्नु सक्छ नि त के हो 15 centimeter भनेको कत्रो लामो हुन्छ भनेर. So you can have an imagination how long the pencil would be. Okay, so that you can see that it's 15 centimeter. All right, but if that person comes to you and says that I have a pencil of, suppose, let's say 0.00015 kilometers, so it's very difficult to understand, right? So if somebody comes and tells you that I have a pencil of 0.00015 kilometers, so that time you'll get confused and you want to know how much long the pencil would be. All right, so you will not be able to imagine the length of the pencil very easily. Okay, so for this reason, what happens is we need to have differently sized units for measuring same physical quantities. So let us say that we have a meter, okay, which is a standard unit of length. All right. So whenever we are measuring something, we tend to say that it is this much meters. है So we keep on saying that. So that is a meter is a standard unit. Okay. So now hence we have other subunits of meters. Okay, which is centimeter, millimeter, micrometer, nanometer, kilometer. Okay. So all these things you people might have heard. Okay. So now let us see what it actually means. So the first thing is centimeter. Okay, so we should know that 1 centimeter in terms of meter, it is equal to 1 centimeter is equal to 10 to the power of minus 2 meters. Okay, so what does this 10 to the power of minus 2 mean? It means that if you divide 1 centimeter into 100 parts, or if you have 1 meter, all right, if you have 1 meter and if you divide that 1 meter into 100 parts, then that one part is equal to 1 centimeter. Okay, this is as good as saying that 1 meter is equal to 1 by 100 centimeter. Understood? So the next thing is uh, next thing is about millimeter. So 1 millimeter is equal to 10 to the power of minus 3 meters. Okay, so what does this mean? This means that you have a meter. Okay, you have 1 meter out in front of you, and then you divide that 1 meter into 1,000 parts. Okay, 1 meter छ अरे त्यो मिटरलाई चाहिँ you divide it into 1,000 parts. So when you divide it into 1,000 parts, so that one part will be equal to 1 millimeter. All right, so this is how we keep on going. Similarly, the next is micrometer. Okay, micrometer, whenever you write micrometer, it is written as 1, and this is a symbol. This symbol is mu. All right, this symbol is called mu. So micrometer, 1 micrometer is equal to 10 to the power of minus 6 meters. Next is nanometer. Nanometer, 1 nanometer is equal to 10 to the power of minus 9 meters. And similarly, if we see, this is kilometers. Okay, so 1 kilometer is equal to 10 to the power of 3 meters. Now, in all these other cases, nanometer, micrometer, millimeter, and centimeter, whatever it was there, we said that it is smaller than a meter. Okay, so it was smaller than meter. That's why in a meter scale, if we are dividing 1 meter into 1,000 parts, then that one part is centimeter. Okay, a millimeter. If we divide that into 100 parts, then it is centimeter. So similarly, this kilometer which you see here, kilometer is greater than meter. Okay, so it is not smaller than meter, but it is greater. Okay, meter one, that's a ठुलो kilometers. All right. So when we are talking about bigger thing, so what will happen now? If you have 1 meter, okay, and if you multiply that 1 meter 1,000 times, okay, so if you have 1 meter and if you add another 999, okay, so then what happens? Meters to it, then it will become 1 kilometer. Okay, so similar, it's as good as saying that. So as you can see here, now we said that if somebody gives us a pencil and says that it is 15 centimeter, okay, but then we won't have any idea about, we will have some idea about the length of the pencil. But if somebody tells that it's 0.0015 kilometers, then we won't have any idea about it. Okay, so it's not that we don't have any idea, but we'll have it won't be easy for us to understand the length at that point. All right, so for specific things we should use the specific units. All right, so now let us discuss some of the special units which are used for special purposes in physics. All right, so there are some special units which are used for some special purposes. The first one is astronomical unit. Okay, so from the name itself, you can say that it's astronomical unit. Okay, so it should be some unit which deals with the astronomical part of the world. So it's somewhat like saying that it is from the outer space. Okay, so what does it actually mean is it is the distance between the sun and the earth. Okay, so one astronomical unit is actually equal to the distance between the sun and the earth. Okay, and why is it used? Why the astronomical unit is used? It is used to measure the astronomical distance. Okay, which means that it is used to measure the distance between the planets. Okay, so once you know the distance between the earth and the sun, okay, so in terms of that you keep as a standard unit, and in terms of that you can also calculate the distance between the sun and the other planets and represent it. Okay, so that is just for the representation sake. We have one standard unit called as the astronomical unit. Okay, so what does one astronomical unit mean? It is the distance between the sun and the earth is known as one astronomical unit. So one astronomical unit is actually equal to 1.496 into 10 to the power of 11 meters. Okay, so this is something which you should know. How much does one astronomical unit equal to? One astronomical unit is equal to 1.496 into 10 to the power of 11 meters. So you can see how much more it is. It is 10 to the power of 11 times. Okay, so that much big of a number this is. So that was about astronomical unit. Now let us discuss about some other special purpose units. Okay, the next one is light year, and it is denoted by the letter Ly. Okay, so what is light year? It is actually the distance that is covered by light. Okay, in 1 year. Now, you people might have understood. Okay, that what does that light is the fastest, right? हामीलाई थाहा छ नि त किनभने लाइट चाहिँ सबभन्दा छिटो ट्राभल गर्छ. The speed of light is only equal to 3 into 10 to the power of 8 meters per second. So we know that the speed of the light is equal to 3 into 10 to the power of 8 meters per second. So it is as good as saying that uh, well, this one light year should be a very big quantity. From that only we can say, हामीले भन्नु सक्छ कि one light year एकदमै ठुलो quantity किनभने 3.8 meters per second मा लाइट त्यति के भन्छ त्यति ट्राभल गर्छ भने हैन that is the speed of the light हो भने चाहिँ एक वर्षमा त कति ट्राभल गरिसक्छ होला हैन so it should be obviously a very long distance, right? So what is one light year? It is the distance that is covered by light in 1 year. Okay, so this is also used for calculating the distance between the planets and uh, the sun, or between two planets or anything like that. Okay, so one light year is equal to the speed of the light into 1 year. Okay, so speed of the light is equal to 3 into 10 to the power of 8, okay, into 1 year. Now when we are taking 1 year, how do we do? 1 year has 365 days, and in 365 days one day has 24 hours, and inside that 24 hours it has 60 minutes, and inside 60 minutes we have 60 seconds. Okay, so therefore we say that 3 into 10 to the power of 8 into 365 into 24 into 60 into 60. Okay, so this whole amount when we multiply, we find out it to be 9.46 into 10 to the power of 15 meters. Okay, so this is actually the value of one light year. So one light year will be equal to 9.46 into 10 to the power of 15 meters. So are you getting it? Right. So we have already discussed why do we need to know or have units. All right. And then we said that units were required for representation of our measurement reading. Okay. And then the next thing that was told to us was that there is a necessity for to have units for different sizes. Okay. So now we are discussing some special purpose units. In there, we discussed about the astronomical unit, which was the distance between the sun and the earth, and it was found to be 1.496 into 10 to the power of 11 meters. And then we discussed about light year. Okay, light year was found to be 9.46 into 10 to the power of 15 meters. So you can see the difference already. Now, talking about this, we have another thing. Okay, the other one is parallactic second. Okay, so parallactic second, or it is also known as parsec. So what does it mean? It is the distance of the semi-major axis of the orbit of the Earth, which makes an angle 1 second. Okay, so this one with the double quotes out here. Okay, so this actually means 1 second. Okay, so now to understand this more properly, okay, the first you see that what does parallactic second or parsec mean? It is the distance of the semi-major axis of the orbit of the Earth, which makes an angle 1 second. Okay, so now what does semi-major axis and orbit of the Earth mean? Okay, so that we'll understand. You people have already seen a protector. I know you people already have a protector with you all. This is something which helps us to find the angles. Okay, so it's like 0, 10, 20, 30, 40, 50, 60, 70, 80. So that way it goes on. So that's the degree. So from 0 to 1, there is 1 degree. 0 to 2, that is 2 degrees. Okay, so similarly, what does this 1 minute mean? This one dash is 1 minute and one double dash is 1 second. Okay, so this is something which we should know. So how much angle does 1 minute make? 1 minute makes an angle of 1 degree divided by 60. Okay, so that small of a angle does 1 minute make. Okay, so if you have 1 degree, if there is 1 degree, so you divide that by 60 times. Okay, if you divide 1 degree by 60 times, that much small of an angle is made by 1 minute. And then 1 second makes an angle if there is 1 minute, you divide that into 60 times some more. Okay, so 1 minute like other 60 times divide. Let's say we get 1 second. Okay, so now what does a parallactic second or a parsec mean? So we have already seen that the distance between the sun and the earth is said to be 1 AU, or 1 astronomical unit. Okay, so now you know that the earth moves around the sun in a form of an orbit, right? So that full orbit, okay, which we have, is known as the orbit of the earth around the sun. So it moves in an path elliptical path. It is not a circle, but it is a kind of an um, how do you tell what's an ellipse? It's somewhat like an shape of a rock ball. Okay, so that's an ellipse. So your earth, it moves around the sun in a form of an ellipse. Okay, and what does the semi-major axis mean? It's actually this one. Okay, so one semi-major axis is equal to 1 AU, that is 1 astronomical unit. Okay, so now it says that it is the distance of the semi-major axis of the orbit of the earth which makes the angle 1 second. Okay, so it is actually a distance from the distance to a point, okay, from the semi-major axis, okay, which makes an angle of 1 second. So this is actually known as a parsec, or a parallactic second. And 1 parsec is equal to 3.08 into 10 to the power of 16 meters. All right. So 1 parsec is equal to 3.08 into 10 to the power of 16 meters. Now we have already discussed the special units which we use to measure the larger uh, lengths, or something called as the uh, astronomical unit, and then the parallactic second, and also about the light year. Okay, so next we are going to discuss much more about the units which we use to measure smaller quantities or smaller lengths for our case. So we have already discussed about the larger units, okay, which we measure the distance between the planets. Okay, now let us talk about the units which we use actually to measure the distance between the atoms and also the molecules. So these are Angstrom and Fermi. Okay, so it is denoted by the letter A with a circle on top. Okay, so this is the your this is something which you like. This is the symbol for Angstrom, and 1 Angstrom is equal to 10 to the power of minus 10 meters. Okay, so this is something which you should remember. So from this itself, we can see that how smaller is 1 Angstrom. Okay, so it is almost 10 to the power of 10 times that of a meter. Okay, so that is known as an Angstrom. Next is Fermi. Okay, so this is a Fermi, and 1 Fermi is equal to 10 to the power of minus 15 meters. Okay, so now let us do some questions to understand and like to reinforce our knowledge on the topic. All right. So we have to convert 325 Armstrong to number one, to meter and to nanometers. All right. So let us do the first one. To convert 325 Armstrongs to meter. So this is 325 Armstrongs, and we need to see how much it gets converted when we convert that into meters. So 325 Armstrongs is equal to 325 into 10 to the power of 10 meters. So why did we write this? Because 1 Armstrong is equal to 10 to the power of minus 10 meters. So 325 Armstrongs can be written as 325 into 10 to the power of minus 10 meters. Okay, so let us do the other one to understand more. We also know that 1 meter is equal to 10 to the power of 9 nanometers. Alright, we already said that 1 nanometer was equal to 10 to the power of minus 9 meters. So obviously from there we can infer that 1 meter will be equal to 10 to the power of 9 nanometers. So once we have this with us, we have already converted the Armstrongs to meters. So it will be easier for us to convert now the 325 Armstrongs to nanometer using this value, okay, that we found out in the first part. So we already have 325 into 10 to the power of minus 10 meters. So now to convert that into nanometers, we just multiply it by 10 to the power of 9. Okay, So 325 is already there. We have 10 to the power of minus 10 multiplied by 10 to the power of 9. Okay, so 10 to the power of minus 10 means actually 1 by 10 to the power of 10 into 10 to the power of 9. The 10 to the power of 9 and 10 to the power of 9 below gets cancelled, and we just have 325 divided by 10, which we can write it as 32.5 nanometers. All right, so this is how we actually do the conversions. So with this, essentially, actually, we have finished the topic on measurement, okay, which deals with the length part. Next class, we'll take up the topic on measurement only, okay, but we are going to take the part which deals with the mass and also with the time. On